quality. Actually, today we focus about the software quality. So in software quality, of course, the software testing assesses software quality. So what's the software quality? It's what the software quality is. So here, if we see what the software quality. So this is from IEEE. The software quality here is the degree to which the system, components, or process meet the specific or specified requirements or system requirements. So in the first, we can say it's first definition or first part of these definitions. The software quality is to meet the system requirements. This is the first part of the software quality. So we have some requirements. So how to evaluate the quality of the software? How we say this software is quality enough? So just if the software is meet the system requirements. So this is the first part of this of the definition of software quality. So from the same resource, IEEE also, they say also the second part of the software quality is the software or it's also the degree in which the system or the components or the process meet the customer or the user need. Customer and or the same customer or user need or expectations. So here, the second part, it's focused on the user or the end need. So if you see the first one, it's just only the customer need. The second one, it's, the system. That means the system, we have the requirements. So let me draw something here. We have requirements now. Okay, the first part of the definitions, the system should meet these requirements. Okay. The second part of the definition, the system not only meet the requirement, also meet the user need. Which is also requirements, but is the user need. So this is two parts of the definitions. It's not two definitions, it's the same definition, but it's two parts. So the question is why we have two parts. Why we have to to meet the satisfy the system requirements, also the user requirements. This is three reasons why there is two fold of the definitions. Actually, that's the errors can come from the requirements. So for example, maybe, okay, we collect all the requirements from the system, we collect all the requirements of the system requirements, but there is some, the user requirement is little bit different, okay, little bit different. So maybe during the requirements gatherings, we fail to collect the user requirements. So this is the first one. And quality attributes also, it's sometimes it's ambiguous. You know what I mean? Ambiguous. That means it's not clear. It's not clear. We have some attributes like you will see today. These all attributes like maintainability. So maybe it's ambiguous. So we cannot measure it. So we have to also see if the user satisfy this, for example, this system or not. So also we need to consider the system or the user requirement. The third one also, there is some standards in the company, or standards that mean they should follow some standards for developments. Okay, guys. So the main idea is sometimes there is a fail for gathering the requirement from the system requirements in terms of the user. So we have also to ask the user about his requirements. Does he satisfy the system or not yet? So I think is by default we have to satisfy the user requirements, also the system requirements. So when we see the user requirements, what do we mean by the user requirements? For example, okay, the system should able to, for example, print something. Okay, so this is system requirement. The system is able to allow the user to log in. So the user now can log in. Okay, but it's difficult to log in. So this is also some user requirements, which is like usability. So guys, here we have question. A product with high quality. A product with high quality, is it's product without faults? Should the product with high quality is without faults? Guys, you can answer. I want to hear you.
Yeah, basically.
Yes, is it correct?
Yeah, but assuming that there is no way to assure that there is no faults, how we can do this like assignment or comparison.
Okay. So another one. I think it's okay. Maybe enough for your this answer. I think he's correct. He's correct. So just this is to approve. This is to approve these things. A product with high quality is not necessary. It's without fault. Okay, maybe if you now just calculate this one in quick. So you see here, we have square 2 and then power 2 minus 4. So maybe what do you think the answer and the result of these calculations should be?
0.
No, not exactly. I think there is no errors here. I mean, the result is, if you calculate it,
I mean 0.
If you calculate it, you know that's okay. This is together will come 2. Because you take the square and then you power again. So it will be 2. And then 2 power 2 will be
4.
Will be 4. Yes, this the result of this will be 4. So 4 minus 4 will be
0.
So, but if we just now obey the calculation, if we do it, I hope I can do it. Okay, we say what's for 2, right? Sorry, let me see. 2 square, right? And then where is the power 2? Power 2. Okay, it's correct. Minus 4. Yeah. It's not
What the heck?
Yes. This is, guys, what do you think this problem? Why not 0?
Is that the floating? No.
Yes.
Is that
yes.
the epsilon?
Because every time the same.
But what about you use square root? You use square root of square root.
I do it 2 times or what?
But why you use square root? In the formula there is 1 square root to the power.
Let me do it again. Okay, where's the how to? So I say I take 2, and then this is double square. Where's that square? Only 1 square.
It's 1 square. 1.
This is square.
Yes.
Yes, it's correct. Now what I have to do is power 2. We have to do that. No square, no more square. This is 1.
Yeah.
This is 2. It's correct. Until now, it's correct. 4.
Yeah.
But now behind in the background of this calculator, there's different calculations. Minus 4.
I think
it's correct until now. I don't do because this is the exception. This one is 2. So it's not wrong. It's not wrong. Believe me.
Yeah. I think the input is correct. Yes.
Until now it's correct, but once I click, it will be like this. If you check it in yours, it's the same. Guys, because in every time there is what we can see the decimal number. So when they round the number to what we can say it's to the integer. No, they don't exactly. They use the decimal number. So it's different from one calculation to another. So it goes like this. We have now every time is not like we calculate. So now here we use, for example, as we see, the result of this is 2 only. But here the result is not exactly 2. not exactly 2, maybe it's maybe it's 1.999. Okay, the same thing, they do it again with the power, so it become difference number, not as we calculated. So after that, the same thing is happening. The same thing for yesterday. If for example, you change from 16-bit to 64-bit, so it goes also some errors. So the same thing, it goes here. So because they round the numbers here in the calculations. So for us, when we calculate, we don't round the number. We just say the square 2, it's okay. It's maybe 1 point something. So power of this number is 2. Is okay. Now it's done. The power is 2. So based on these two, we continue our calculation. But in fact, they don't use 2 because maybe the square is not exactly. I mean, the square 2 and the power 2 is not exactly 2. But in our calculation, we say it's 2. So this is, as we say, it's small faults. It's not exactly faults, but they use maybe, as we say, it's the round is the problem here. So this is actually a proof that there is, it's not, you can try it at home or you can try it later and you see. Even this is, everybody use this calculation, but there is some fault. Okay, guys, we continue with the quality. So as we say here, the quality is subjective and relative. So what we mean by that, maybe as you know, it's a subjective. Anything is subjective. That means it's different from one perspective or from one person to another person. So if you are in, for example, you are IT students, right? So once you buy your laptop, you will have many requirements. Maybe for another one, he just maybe buy a laptop just to maybe to browser YouTube or browser anything. So it's just anything. So you will look to the quality from different perspectives, and the same thing to other one. So also another things, also this is, I mean, is different perspective, different user. It's look to the quality from different perspective. Also in the business, also it's also this one is also affect the definition of quality. So the company will not continue, for example, testing the product for forever. Of course, they have some limit times, even it's because the user or also because the profit. So they want also make some profit. So we cannot spend long time for just testing the product. So this is also affect the definition of quality. So this is also how we can also measure. Okay, we say here there is objective and subjective way to evaluate the quality. So there is also in somehow we can say we can measure the quality. So sometimes, okay, measure the quality, for example, against the requirement. So this is, we can measure it. It's easy, but sometimes how to measure the usability. So this is, there is some way to measure the quality. Okay, for example, if it's objective, okay, for example, the requirement. So we have some factors need to meet, for example, the performance, the operation of the system. The system, it's operate well. The system, it's do its job. So this is, it can be measured. Something cannot be measured, like for example, okay, the user requirement. So this one, we don't have way. We just maybe have way to ask the user about its feeling after using this software. Here we have also some methods. Here just the methods that use this, for example, how we can measure the user feelings. So it's quite difficult, but there is also different type of testing. For example, user acceptance testing. This is just give the user, for example, 10 users or 100 users based on your system, some the applications or the application, and they also give them the form. So then ask the user to try this application and then fill up this form. So this is the simple testing, which is user accepting testings. So this one, maybe as we say, this is in terms of a subjective issue. So how we can measure it. We can use this kind of testing. So we still also in quality. So now we talk something about the quality, and maybe you know something about the quality. So what's kind of factors? Because here we talk about the factors, right? There is some factors can measure the factors. So here the question, what kind of factors make up the software quality? What the factors that make up the software quality? Okay, here this you can go to Miro and share your opinion. Okay. Okay, we have, as we see, just go here and then the second. Every time just open this one because this will open it as tabs here. So what type of factors can measure? Can make up, not measure. Okay, hello guys. I think all the answer is correct, especially drinking coffee. So guys, actually all this even sometimes use different, you can say different terms, or for example, or different expression to express your answer. So here, for example, stable software. Yes, we can say it's, we have some factors, maybe okay, this one can be goes under operability, because here some people they write the correct one. For example, the usability, maintainability, flexibility. I'm not sure. I don't think this one, flexibility, maybe is different or incorrect words. Exactly, maybe there is something similar to the flexibility, but not exactly flexibility. The complexity of the algorithms, yes, yes. Performance, integrity, reliability. Okay. This one maybe same. Function, security, portability. This one maybe you can say is the same, right? Portability. No, different. I mean operability. If you can see this one, it's almost same. So guys, okay, all the answer is correct. I just maybe from flexibility, how we can say that system is, or it's this one is the flexibility. In somehow maybe if you want to say the portability, I think it's okay. Maybe it's a synonym for flexibility in terms of testing, because this maybe is difficult to say flexibility. Okay, guys, so all is correct. So here. So of course, guys, as you know, okay, once we talking about the software quality, there is some we can say some factors that's make up this quality. So as you mentioned, there is the maintainability, the security, portability. So we have many factors. I will not go through this because we have, I listed all now. This is what we call it. It's the 8 dimension of software quality. So here is the 8 dimension of the software quality. Okay, to produce high quality software. So you should back to this list and then see, have you satisfied all these 8 dimension or no? So let's see the first one, what we mean by maintainability. So maintainability, that means, okay, after finishing your code, your development, so how easy to edit or modify this code? So this is the first one. I think it's clear. So if I ask how to measure that, your code, it's maintainability or maintainable. How to measure this point? Hello guys, do you hear me?
It's
Yes.
modular and well written.
Yes, guys.
Well commented.
You can talk.
It is modular and well commented.
I think there
Modulars.
should be some.
Okay. We have something similar to that. Okay, this is also one things we can say this also to say that. But if you say, okay, as we say, you have the code now. You have the code, and you, of course, if the code is in small modules, maybe it's easy to maintain. Is okay, but okay, you have the code. Suppose okay, you are in one modules, and there's some bug or some problem there. So how it's easy to catch it? How to measure that?
There should be
Easy
good
to catch.
architecture of software.
Mm-hmm.
The good architecture of software.
Maybe yes, can actually this is we put it under use the button, some buttons. So maybe you or other one use the same button, so it's easy to catch the errors. Also,
Maybe some layers which are responsible for some functionality.
Yeah, can also. So here also, guys, we have some techniques. Actually, you know, guys, the complexity, how to measure the complexity of your, for example, you write just a few lines, just maybe loop, and if loop, okay, for or while, okay, and then you write some few lines inside. So how to measure this one? I mean, something is, we can say systematic way, just we have something to measure these things actually, which is the complexity.
N raised to means O raised to in this. How much time, the time complexity you mean?
Yes, time complexity, which we call it is the big O, or here they call it also, there is another way for in cyclomatic complexity. Also, we can measure it by the line of codes, how many lines you have. Of course, if you have 100 lines, it's different than if you have, for example, few lines. So this is also a way to measure the maintainability of your code. So it's not that difficult if you go for, okay, of course, when we say about the what we can say the modules, actually we have here another factor, which is which one is, I think we have another factor related to the modules. So the first one actually we say is the maintainability. So how to measure it? So we have some, as we say, of course, your answer is correct. I mean, small modules, many modules, is separate modules. Also, this is also can affect the maintainability. Okay, the second one is the portability. The portability is okay. How easy to move your software to another environments. So this is also, it can affect the quality. So how to test this, how to measure this, the same thing, I put it here. You can say this is maybe just, okay, just one normal testing, which is, for example, okay, setting realistic testing environments. Okay, you design your system on one environment. Also, you have to check your system in different environments. So this is also affect the software quality. So the third one, which is the functionality. So the functionality, so the system do what is expected to do. So this is the functionality. So how to measure that? There is different testing techniques. I just maybe mention something of it is user acceptance testing. So this is It's easy also, it's not difficult. We have unit testing, you have system testing. This is different type of testing, because now we are talking about the requirements. So how to measure the requirements? We have different type of testing to, if bus, that means your system is functional well. Also is the performance. So I think it's clear what I mean by the performance. So performance, it's the system, it's work under the workload. So if your system, for example, design for, or you during the system, the design, okay, you design it, okay, and then you test it under only, or you test it by one user. But in fact, this system should accept, for example, in the same time, hundreds of users. So this is, we should test this one. We should test this one. And the second, this is, we have also different type of testing. The stress testing, also, this is if there is something related to the networking, the internet. So also the time of, for example, loading this page, for example. So this is also one factors. So compatibility, okay, how well the software run on different browser devices or operating system. Okay, so guys, you see there is maybe this one, how we can, I do write here, how to, of course, maybe I post it up some, or test the system on different platforms, I think so. Yeah. So the usability. So here also, how easy you can your system can be understood and used. So this is also how we can measure that, also by do accepting testings. So we mentioned many times the accepting testing, because this is the easiest test can be done, which is, as we see, no need to do anything, just after designing, after this is maybe most of maybe final year project requirement is to test your application. So how to test it? You can use the user accepting testing. You need to go for anything, just this one. As I mentioned, you give your application to someone and then you give him a form. So he will go through this window one by one, or and check, okay, for example, the search button is working, the login page, it's working, something like this. Reliability, okay, how system is fail, how likely your system is fail. So this one you have to apply also, it's what we can say some testing techniques, and this is actually we will learn and then also use this unit testing. Your system, you divide your system into units. The units can be anything. For example, modules. Each module can be unit. Buttons. So each buttons can be modules. Each function can be modules. Can be unit. Sorry. So any components in your system, it can be unit, and then you test that unit. So this is a very important one. We will use it. Also, we will do it in the exercise 4. Okay, unit testing. As we mentioned, it's important. It's also easy. It's not that difficult. So integration testing also, it's required here. What's the integration testing? Integration testing is, okay, so you see here we have a unit testing. So you divide your system into units until you test each unit. So this stage is passed. Okay, all the units is working well. So now we have to combine all these this unit into one system, because your system should work together in the end. So this is what we call it is the integration testing. So once we combine all these modules together and then test it together, so this is integration testing. Accepting testings, the last one. Security, of course, it's how vulnerable your software to any attack. So here, how to measure that? Okay, if you have number of incidents, number of bugs inside, or weakness in your system. So this is, guys, how to measure. Of course, some of them it's difficult to measure it. But I'm trying to give against everyone is the way to measure these. What you can say is the dimension or factors. But some of them is difficult because it's subjective, and some of them it's okay, easy. For example, something like the functionality. You have requirements. The system should, for example, produce, for example, the sum of two numbers. So the system will produce it. This is it's not that difficult. So maybe this is what we can do. Also, it's in the unit testing. You have two numbers, so the system should produce or print out the sum of this number. So it's not that difficult. But when you talk about the usability, it's quite difficult to measure the usability because it's subjective, it's not objective. So guys, maybe this is the last things in the top, in the quality. So we talk about the quality. So when you will add or implement, see guys, I say add or implement. So this is the question, and then you answer the quality in your system, in your life cycle, in the development life cycle. When you will add it, or when you will apply it, and when you will implement it. We talk about the quality, and this is the life cycle, right? Any system development life cycle. You know that, guys, this is the life cycle of any system. First, we start with requirement, and then design, and then implement, and then testing, and the end is deployment. Deployment, that's mean install and maintenance. So guys, where and when, in which stage we have to apply the quality? Hello, guys.
Testing stage, probably.
Again, testing the same
stage. Yeah.
Okay.
Actually, even the planning stage, initial first, you can structure it in such a way where you can plan out the quality beforehand, what you need, so that all the stages have the quality inspection incorporated into them.
Of course, yes, guys. We cannot just work, for example, after implemented, for example, the code, and then we add the quality. Testing, for example, you say testing, it's not the correct answer. Cannot put it. I mean, the quality in the testing. Testing is time to test the software. So, for example, when we talk about functionality, your system should work well. So this one, if you just later add it, for example, now in the design, we design that thing, the functionality, and we do it. We design it and then we implement it. Here in the test, we just test it. We test that is your system work well? Then later, if not, we come back to design again. So as your mate say, actually, the quality should build in all these stages. Even the testing, as we say, the testing is just to test, right? The testing is just to test, but also we can build in the testing, the quality in the testing, how to, for example, use the quality testing techniques, or to done it in a good manner. The testing itself. Once you do it well, that means you will revise all these design and implementations. So quality is not just something to add it in the end or in one stage. So it's built in all these stages. Okay, guys, I think this one should be also clear, because when you gathering the requirements, also you should consider the quality. That means you should use some good techniques to gather the requirements. In the design, the same thing, because the faults can come from any of this stage, the requirement or the design or the implementations. Okay, why we don't talk a lot about the testing? Because actually we consider that after implementation you have complete system, and now you come to test it. After that, deploy it. So here is the most important thing: is the first three stage. So, but not only the quality in this three stage, but in all. So where is the software testing? The testing in the quality. Actually, we can say we have the quality assurance is the process that's used to avoid any defects. Then we have a set of activities that can be used in the quality assurance. And this set of activities, we call it quality controls. So under this, one of these activities is testing. Okay, guys, we say now we have a big umbrella, which is the quality assurance. Okay, this is just a process to avoid any defects. So how we can implement that one? So by do some activities. And these activities, we call it the quality controls. These activities, one of them is testing. Testing is one way to detect these defects. That means it's one activity under the quality control, which is also under the quality assurance. So this is the relation between the quality and the testing.